In this lesson, Unit 5, Lesson 1, we are going to be talking about exponential functions. Okay, so most of you know a linear function. And a linear function, just as a little review, linear looks like y equals mx plus b. Okay, an exponential function is going to have to look something different. So over here in the box, we have an example of an exponential function. So an exponential function is f of x. Remember, f of x is the same thing as the letter y, so they're interchangeable. Y is for an equation, f of x is for a function. But here's the part we got to work on learning right here. It will have the form of a times b raised to the exponent of x. A is your initial amount, or as I like to also call A is your y-intercept. And B is the constant ratio. And the constant ratio is also considered the pattern of multiplication or division. Okay, remember for linear, the pattern was addition or subtraction. So then exponential has to be opposite, and that's how we got multiplication or division. So now off to the side, we have a box that has a whole bunch of fun information in it. So let's look at this. Definition for exponential function is it says you have an initial amount and a constant ratio to a power. And really not anything you have to worry about there. The next bullet, once again, this tells me the formula. F of x equals a times b raised to the power of x. Okay, now the last two bullets, these are important because we are going to ask you to be able to look at problems and tell me whether it's an exponential growth or whether it's an exponential decay. So how do we tell the difference? You're going to look at the letter B in the formula. If B is greater than 1, it is a growth. And if you're looking at a picture, then that means from left to right, the numbers are increasing. If B is less than 1, then that means it's a decay. And from left to right, the graph is going down, decreasing. Now, our next box with exponentials, we now have another new term, and that new term is what we call the asymptote. And asymptote is always going to be a horizontal line. And if it's a horizontal line, all horizontal lines, if you remember Hoivux, the Hoi part, they start with y equals. And then, well, what would y equal? What is that number going to be? Well, if you look over here to our function, we added a little bit more to it. So we have a times b raised to the x, but now you see that we put plus or minus c. So you could have plus 10 behind it, you could have minus 4 behind it, but whatever that number is, that is your asymptote. Now, what does an asymptote mean when I'm looking at a picture of a graph? Well, an asymptote is going to be a line that we get closer and closer to, but we never really cross it. We ever get so close, and we'll get so close that the calculator will just call it that number and stop, but it doesn't really ever approach that number. So anyway, let's try some problems where we have to worry about all of this. So my first example It says classify each as an exponential growth or decay, fill in the table of values, make a graph, and then answer all the key features off to the side. Okay, to help us make a graph, we are going to use an online graphing calculator. So if everyone could go out to the internet and if you could type in Desmos graphing calculator. So you'll see that I have it right here on the screen. It's the very first one that pops up. Click on that. Okay, and then we are going to type in, let's see, what does y equal? On our first one, y equals 2. And then to get an exponent, you're going to have to use Shift 6. Okay, so to make an exponent, I'm going to hit my Shift key and then 6, and you're going to notice that it moves it up as an exponent. And then I get to type in X, and voila, it makes the picture for me. And exponential functions are not straight lines. Straight lines are linear. So exponentials are curved. So does everybody notice that we have a curved line? Okay, awesome. To fill in the table on your screen, everybody go to the, looks like a little gear wheel here. So if I click on that, it brings me to the screen. And then right here, you'll see one that says convert to table. So I'm going to click on that. And then voila, it gives me the answers for my t-table. So on my t-table back here, I'm going to go -2, which was 0.25. -1 is 0.5. 0 is 1. 1 is 2. And the last one, 2 is 4. Okay. Now, I'm going to go off to the side and I'm going to plot these ordered pairs. So -2 and then 0.25 is just a little bit above it. So there's my dot. -1, 0.5 is about halfway. 0, 1. So in the middle, go up 1. 1, 2. And 2, 4. Okay, now if I go back and I look at my graph, do you notice when you go back and you look at your graph, if you're on the left side here, you're going to have your graph. It's curving, and then it looks like it's curving and it gets right here, really almost on top of the x-intercept. But if I came over here, I don't know if everybody can see where I'm clicking, but this part right here is really close to the x-intercept, and it doesn't ever actually go through it. Now, if I get rid of my table, whoops, I didn't mean to make my picture go away. Give me a second to get that back. Okay. So here, when you look at this, if you look at the y value, you know it's 0.004. And then if you come all the way to this one and you look at it, it's 0.002. So it looks like it's on 0, but it's not actually on 0. It's just getting so close to it. So anyway, when I come back over here to make my graph, I'm just going to make my line as close to 0 as I can until I start hitting my points, and then it's going to curve and go on forever and ever in each direction. So is it a growth or is it a decay? Well, remember our formula, y equals a times b raised to the x. So b is the part that has the exponent. So is everyone okay with saying my b is the number 2? And 2 is larger than 1, so it's a growth. Or if you look at the picture from left to right, it's going up. Y-intercept. Well, where does it cross the y-axis? And it crosses the y-axis right here at the point 0, 1. So if you look at your t-table, wherever you have 0, you should have a y number, so that's your ordered pair. Asymptote is always going to be y equals. And then what number do I get really, really close to but never go through? And hopefully everybody notices that's where we were talking about. It gets really close to the x-axis, which is at the y number of 0. Okay, then we got 2 new terms, domain and range. Domain is the x numbers, and range is the y numbers. So domain, if I'm talking x numbers, do you see on the left side we have this little arrow, which means it goes on forever and ever on the left. And then on the right, as it's going up, do you notice that it's actually going out as well? So we're using all the x numbers on the right. So my domain is everything. So everything is what we call all real numbers. And the good news is that every exponential function here will have the domain of all real numbers. Now on the range, we have y, because range is y numbers. And then if you notice, all of our y numbers are on the top portion of my graph. Okay, so we're going to say here y is greater than. So we're always going to have greater than. And then asymptote is at 0. So remember, it never really touches 0. It gets really, really close to it. But then we have all the y numbers that are above 0 on my graph. Now, remember, if you were looking over here at the equation, we said that the asymptote was also the c number. And this one doesn't have anything behind it in the c number, so that's like saying plus 0. So that's how I knew the asymptote was 0. So hopefully the more of these we do, the faster we get. So on the second one, okay, the first thing, I'm going to go back to Desmos and I'm going to type that in. So 1 divided by, so I hit my little slash for division, 2. Then I'm going to arrow back out, shift 6, exponent of x. Then I'm going to arrow back down to get out of the exponent, plus 2. Okay, so then I'm going to go here to my little gear, and then I'm going to click table. And here is the values I'm going to copy down into my table. So -2 is 6, -1 is 4, 0 is 3, 1 is 2.5, 2 is 2.25. So now I'm going to go over and I'm going to plot these. Boom. Boom. Boom again. 2.5. 2.25. So hopefully everybody notices this time. We're going this direction. And there's my picture. Woola. So my B number is 1/2. And 1/2 is less than 1. So that means it is a decay. Or you can look at that picture from left to right. It's going down. Y-intercept. Well, if I look on my chart, the y-intercept is 0, 3. Okay, asymptote. Y equals, oh, look, I have a C number. I have a C number. And at the end of the equation, I have a +2. Or if you're looking at your picture, you're going to notice here that it's getting ever so close to 2, but not really actually crossing it. Domain is always everything. So all real numbers. Range. Y is greater than 2. Okay, third one. Let's see if we can answer these questions without having a picture. So for growth or decay, we need to look at the B. So remember, the B is the part that has X attached to it. So my B is 1.8, which is larger than 1, so it's growth. Y-intercept. Now, on the y-intercept of this one, I have to do a little bit of calculation. We know the X number has to be 0. So I'm going to pick up my calculator and I'm going to do 2 parentheses 1.8 raised to the 0 power minus 1. So I'm going to type that into my calculator. And when I type that into my calculator will give me the answer of 1. So I have 0, 1. Asymptote. Asymptote is always y equals C number, and my C number is -1. Domain is everything, all real numbers. And range, y is greater than my asymptote number, which is -1. Done. Okay, on the back. This time, I'm going to give you a table or a picture or some ordered pairs, and I want you to write the exponential function. So remember, exponential functions have to look like f of x equals ab raised to the power of x. And remember, once again, a is the y-intercept, and b is the pattern for the multiplication number. Okay, so when I'm doing this, I've got f of x equals y-intercept. As everybody see on the table, we have 0, 4. So that means that my a is 4. Okay. Whoops, sorry. My screen just switched on me. Let me switch it back for you. Now my b. So for the pattern numbers, we're looking at the y's. So how do I make 4 become 12? What would I have to multiply it by? Or you could say, what do I multiply 12 by to make it become 36? And hopefully everybody says 3. Well, what if that doesn't jump out at you? What could I do to also figure out the multiplication number? You could also take the second y number and divide it by the first y number. So if I take 12 and I divide it by 4, that will give me 3. So then I come over here and I have 3 raised to the x. You can put parentheses or times dot. I don't care which one. Done. So let's look at the next one. Y-intercept. So my y-intercept is right here with this blue dot. So to me, that's going to be in between. So 1.5. And then for my b number, I need to pick another nice, neat point on my curve here. So I got this point, and I'm going to do this point. Okay, so this y number was 1.5, and this y number is 0.6. So I'm going to do 0.6 divided by 1.5 on my calculator. So remember, second y divided by first y. And if I do that, I come up with 0.4. So now I can say f of x equals 1.5, parentheses, 0.4, raised to the power of x. Okay. Then we can have it listed as ordered pairs. And if it's ordered pairs, my y-intercept, here's the point that says 0, 3. So that means my y-intercept is 3. For my b, so I'm going to do second y over first y. So 12 over 3 reduces down to 4. So f of x equals 3, parentheses, 4 raised to the x. Okay, last thing before you get to do some on your own. Okay, the last problem wants you to look at this table and tell me, is this table representing something that's linear or representing something that's exponential? So off to the side, we need to remember linear, the pattern is adding or subtracting. Exponential, the pattern is timesing or dividing. And remember, we are focusing on the y numbers only. Okay, so the first problem, if it jumps out at you, great. If not, we're just going to check one. So let's say I wanted to see if it was exponential. So if it was exponential, then I would do y2 over y1, which would be 4 over 7. And then y3 over y2. So it's always the next y over the previous y. Well, that would be 1 over 4. And then I would say, oh, stop. 4 over 7 is not the same as 1 over 4. So it can't be exponential because my ratio would have to be the same all the way through. So then I would say, to exponential, no, no. So then I would say, let's check linear. So if it's linear, I notice my y numbers are getting smaller, so let's check subtraction. So 7 minus 3 is 4. 4 minus 3 is 1. 1 minus 3 is negative 2. And negative 2 minus 3 is negative 5. So yes, the pattern is subtracting 3 the whole time. So yes to linear, yes to linear. And our reasoning is the pattern is subtracting 3. So let's go to the next one. Okay, so let's say we were going to check exponential. So if I'm checking exponential, I would have 3.5 over 1.75. And if I divide that out, I come up with 2. And then if I take 7 and I divide it by 3.5, I come up with 2. If I take 14 and divide it by 7, I come up with 2. And one more time, 28 divided by 14 is also 2. So everybody okay that my common ratio is 2? Or if you want to come up here and say, I noticed when I looked at the chart that if I multiplied each number by 2, I got the next number. That's completely fine too. So yes, winner, chicken dinner is exponential. And it's because the pattern is timesing by 2. Okay, so now you're up. Remember to get full credit on your notes. You have to try these problems before you come into class, because otherwise it defeats talking about them if nobody has tried them. So good luck. We'll talk about them in class.